All right, let's take a look at problem number 2. So we have, for problem 2, we're going to graph a function, f of x as a cosecant function this time. F of x equals negative 2 pi cosecant pi over 2 times x minus 1 plus pi. Okay? All right, now since this is a reciprocal identity, we have to use the related reciprocal function to graph this function. All right, so what is the related function here? Let's write that down. The related function is f of x equals negative 2 pi sine pi over 2 times x minus 1 plus pi. So how do we know this? We remember our reciprocal identities. We know that cosecant theta is equal to 1 over sine theta. All right, so we're going to graph the reciprocal, which is a parent function, and then we use that to generate the graph of cosecant. All right, now that we have the related function, let's find the properties of our function, the related function first. We're going to start with the new origin. Okay, so new origin. The new origin can be determined by finding the value of hk. Okay, so what is h and what is k? We do not know. Let's go ahead and write down the standard form for the equation of a trig function up here. F of x equals a sine b x minus h plus k. All right, so we can see that b is pi over 2, a is negative 2 pi, h is 1, and k is pi. All right, so our new origin is going to be positive 1 comma pi. Remember that anytime, because of this minus, any number you have after the sign next to x, you have to take the opposite of that. Okay, so that goes the new origin. The new origin tells us the shifts. The phase shift is the shift along the x-axis. That's h, and that's 1. This means that we're going to be shifting 1 unit to the right to our new center because it's a positive and in the x direction. Next is the vertical shift. Vertical shift is the movement along the y-axis, sorry, and that's determined by k. Our k is pi. Since it's positive, that means we're going to be going upwards. Next thing we need to find is the amplitude. The amplitude can be determined by computing the value of absolute value of a. Okay? In this problem, a is negative 2 pi. So we have to determine the value of absolute value of negative 2 pi, which is equal to 2 pi. And that's going to be going in the x direction also, up and down, from the center to the max and the min. Next, we need to find the period. The period can be determined by computing 2 pi divided by b. Okay? You can see in this problem that b is pi over 2, so we're going to calculate 2 pi divided by pi over 2. Now, how do we divide by a fraction? All you simply do is multiply the numerator by the reciprocal of the denominator, like that. You notice that the pi's cancel out, and you're left with 4. Okay, this value 4 is our period, and also can help us calibrate our x-axis. Since we have 4 quadrants in a complete cycle or period, we can take advantage of that and let 4 ticks equals our period, which is 4. All right. Now we need to find the frequency. The frequency can be determined by calculating b over 2 pi or the reciprocal of our period, right? Our period is 4. If you reciprocate that, you get 1/4, and that's our frequency. Now let's set up the window to help us graph our related function. And then we'll use the graph of our related function to generate the graph of the actual function. Let's divvy up our workspace. So to start that off, we need to write down, put the new origin, position it at the center, 1 comma pi. Now going up and down, we're going to go with this magnitude of the amplitude, up and down, and then side to side, add and subtract the period so that we can have two periods relative to the new origin. Now since our amplitude is 2 pi, we're going to add 2 pi. Okay, and subtract 2 pi from our y-axis, okay? I'm going to keep track of that because our y-axis goes up and down. Pi plus 2 pi is 3 pi. Pi minus 2 pi is negative pi. Now let's go side to side. We're going to use our period. Our period is 4, so we're going to add 4. Now we're working with the x-coordinate. 1 plus 4 is 5. And then on the other direction, we're going to subtract the period also. Minus 4. 1 minus 4 is negative 3. Okay? All right, so these are the dimensions of our window to ensure that we have a good picture of the indicated graph. Now let's set up our coordinate system. Taking full advantage of the window we just created, you notice that our quadrant is in, our new origin is in quadrant 1 since they're both positive. So let's keep that in mind. Now, how do we position our axis? These aren't too far apart. -3 and 5. We just put it somewhere, shift it a little bit, shift your y-axis a little bit to the left since -3 is smaller than 5, but not by a significant amount. And then let's look at the y's. This is much bigger, so we have to shift down our x-axis to compensate for the size of our maximum. It's so big. Okay. All right. So there we go. Now let's calibrate our y-axis first. We're going from negative pi all the way to 3 pi. So 1, 2, 3. 3 pi. Okay. Now let's do our calibrate our x-axis. This is our y. Now to calibrate our x-axis, we're going to take advantage of this. 4 ticks equals 4. So to the right, we're going to go 1, 2, 3, 4. All right. And then to the left, 1, 2, 3, -4. Now, if 4 ticks is equal to 4, then that means 1 tick is equal to 1. So where is 5 going to be? It's just simply going to be a tick over. Put 5 right there. -3 is going to be right here, -3. Now let's go ahead and graph the center of our related function. The center is 1 pi. So this is 1 right here. 1 and pi. Let's draw our x-axis. The horizontal line through the new origin. And then our y-axis is a vertical line through the new origin. Now let's graph our maximum in. The maximum displacement is 2 units from the center, 2 pi units from the center. That takes us to 3 pi. And then our minimum displacement is 2 pi units from the center, which takes us to -pi. Okay, we're graphing let's see what we're graphing. The sine function, and we know what the sine function looks like. Looks like an S. But our sine function is negative this time. We have a negative there, so instead of going up, we're going to be going down to the right. Let's go ahead and graph the points. So we'll start from a new origin. 1 tick mark to the minimum, that is negative. 1 tick mark back to the center, 1 tick mark to the maximum, 1 tick mark back to the center. That is one complete period of our negative sine function. To the left, since we went down to the right, we go up to the left. 1 tick mark to the max, 1 tick mark back to the center, 1 tick mark to the min, 1 tick mark back to the center. There's another period to the left. Okay? Now let's connect the dots. We're going to be using a dotted line here because we're not graphing the sine function. We're graphing the cosecant function. Okay, so keep that in mind. So let's go ahead and do it. So dot, dot, dot. Like that. Concave up to the center, concave down to the max, concave down to the center, concave up to the min, concave up to the center, concave down to the max, concave down back to the center. All right, now our related sine function tells us where the asymptotes are located. All right, so we have one asymptote here, one asymptote there, another here, another there, and another there. How do we know that the asymptotes are there? This is where the new function intersects with the horizontal, with our central position. Okay, wherever you have that situation, you're going to have an asymptote. Okay, so let's go ahead and graph the asymptotes. So we have one asymptote right here, have another asymptote right here, or vertical asymptote, have another asymptote that coincides with the new y-axis, and then we have an asymptote right here, and then we have another asymptote right there. Okay, every 2 units you have an asymptote. That pattern continues forever. So how do we draw our cosecant function? We just simply reflect the use of our negative sine function up and down depending on the orientation, and that will be the answer. So let's go ahead and do it. So this opens up, we reflect it downwards like this, opening down. This opens down, so reflect it up, opening up like that. Let's do that again, that doesn't look good. So this one opens up, and this one opens down, reflected downwards, and then this portion opens up like that. Okay, so the green function is actually the graph of our cosecant function. The blue one is a guide, so you can erase it. Let's say it's on a test, you can erase the blue function, or because that's not what we're actually graphing. Is the green function that's the final answer. Okay, so I'm just going to leave it there because it's a guide to help you see how I came up with the final graph. Okay, so let me just fix this one. This portion right here, you get really close to the asymptote without touching it. Okay, so this green function is our cosecant function. So that's that. So thanks so much for taking the time to watch this presentation. Please feel free to subscribe to our channel so you can get updates to other cool clips such as this. And do give us a thumbs up if you like this clip and post a comment to let us know. More clips coming from math.serve.com. Thanks again for watching and have a wonderful day.